find on the internet, but there's my email address right there if you want to get a hold of me or have any sort of follow-up questions or comments that we don't get to today. So I'm going to be talking about a coarse filter approach to conservation of wildlife habitat and wildlife itself. And I would really go bigger than that and say it's more of an approach to conservation of biodiversity broadly. Now, I've used this term coarse filter for actually literally decades now, and I'll just admit to you that I had to go look up what the origins are, and I wanted to trace it back as far as I could and start there. When we talk about a coarse filter approach, I'll start with a misconception, and it's one that I had, is that it means really large spatial scales. And it can mean that, but that's not really what we're talking about. What we're talking about when we talk about a coarse filter approach is what are the practices, the types of things that we can do and get most of the way there. So let me try to say that a little bit differently. If our goal is to conserve wildlife or biodiversity, what can we do? Most of the time, most places, it'll get us most of the way there without having to take a targeted individual species focused approach. So that's really the origins of the coarse filter approach to conservation. It started in the late 70s and early 80s with the Nature Conservancy, and it was an approach to reserve design and identifying what places to go and acquire and manage out on the landscape to meet their objectives of biodiversity conservation. And, one of the things that happened pretty early on by the mid 1980s was a really important elaboration to the coarse filter idea and that approach to conservation, which was the recognition of the overriding importance of disturbance processes and disturbance regimes in generating habitats and the habitat mosaic. And, I'll show this picture I've got on the screen many times over the course of my presentation today. But, if we look across this landscape here, this samples a huge environmental gradient from the top of the mountain all the way above tree line down to the valley floor and all of the different ecological communities that organize themselves, the different species. We can find whitebark pine at the top, we can find cottonwood along the riparian areas and everything else in between. But when you look at the variation, the patch structure, all of the complexity in this picture, we can't explain really most of it without bringing the disturbance regime into our understanding and our approach. So that was a really important early development in the coarse filter approach, is that we've got to think not only about particular communities, plant association groups or habitat types or whatever you want to call them, and making sure that we're representing those in a conservation strategy. We also have to elevate and consider the disturbance regime and how that interacts with the biota. Now, this started out as really a conservation approach. Like, we're talking about reserve designs, places that aren't going to see a lot of active management or maybe even any. So how do we get from there to using a coarse filter approach in managed landscapes? And that's what I'm going to talk about for the most of the day. So here I'm showing you a picture looking out across the central Blackfoot. And, this is, for the most part, a managed landscape. There's not, in this picture, there might be individual areas that are managed as reserves, but we've got a mixture of private, state, federal lands. Almost all of them are available and have as an objective active management, including wood production, commodity production. But most of these lands also have an explicit goal in one form or another of biodiversity conservation. And so one of the things that I want to be really explicit about right at the start is that when we're talking about, hey, we're going to use a coarse filter approach to conservation, what that means is that your landowner, whoever the landowner is or the agency or whatever setting you're in, has identified conservation as a goal. and not just as a constraint. And there are many forest landowners who totally appropriately approach conservation primarily as a constraint. It's something that society imposes through laws and regulations on their operations. But in this case, when we're talking about a coarse filter approach, we're talking about conservation as a goal. And now coming back to disturbances and how they can help us or be informative in this sort of a coarse filter approach and managed landscapes. So this one of the central assumptions or really assertions that I'll make and that all of the science and literature that I draw on makes is that the natural disturbance regime in your landscape provides a model that we can use to inform our manipulations, our active management of forest structure and composition, the conditions out there on the landscape. So I'm going to put forward ecological forestry as the preferred, or my preferred anyway, framework for implementing a coarse filter approach. And this is now, I would call it a pretty mature body of science and practice. Ecological forest management, it has been kicking around in the forestry literature and science since at least the 1940s. And since about the 1980s, it's really undergone a lot of development of ideas, of practices, and now it's become a pretty mainstream and formalized part of the overall forest sciences and forest management um, body of theory, I'll say. And two books, important books. Unfortunately, we can't put these in the OneDrive folder, but I think that every forester and really every wildlife biologist should have both of these books on their shelves, maybe even read them. Are these text by Franklin et al., Ecological Forest Management, and then for more of a practical and stand level focus, the new Ecological Silviculture text by Palick et al., which is just out in 2021. But what is ecological forestry, and how is it a coarse filter approach to conservation? So it's a system that really draws first and foremost on ecological knowledge, ecological science, and as an explicit goal, we're seeking to sustain ecosystem integrity and biodiversity. So it's embedded in that coarse filter idea. And crucially, it's an approach that emulates and is compatible with the natural disturbance regime of the region and the landscapes that you're working in. I don't think that's enough to be able to explain it. I've taken this table and adapted it from all of these sources here listed at the bottom, but I think it's helpful to be able to try to, when we often have to explain what we mean. Well, let me back up and say this differently. Most of the world, unfortunately, is not are not most of the people in the world are not foresters, and to most people, forestry is forestry is forestry. It's all the same thing, and many of them that we have to interact with as professionals, members of the public, some of our clients, our colleagues, including colleagues who work in the natural resources professions, but maybe in other disciplines. Really, if you tell them, hey, we're using ecological forestry as a coarse filter approach, they're not going to know what you're talking about. And so one way to try to sort of identify some of the differences and key ideas is to look at this gradient here. If we say, okay, we can contrast ecological forestry with a production forestry model. So this might be an approach used by, for example, a publicly traded real estate investment trust that is primarily concerned with managing forests and growing trees to generate return to the shareholders. So this table, I think, is a useful way to begin to explain some of the ideas that are embedded here and help your clients and your colleagues understand what it is we're talking about. So one of the key differences is what are the primary sources of information that we draw on? In ecological forestry, as I've already said, we're going to primarily lean on ecological science first. where in a production forestry environment, you're primarily using agricultural models and science and economic models and science as a basis for your management. Major differences emerge when we look at how we interact with disturbance. Ecological forestry, you tend to want to work with and within the limits of the natural disturbance regime, as opposed to trying to evade or avoid natural disturbances. We tend to be focused on I'll call it a portfolio approach, so maintaining stability, resilience, and multiple outcomes and services in ecological forestry, in contrast to optimizing a single output. And there's a lot of attention and emphasis focus given to maintenance of structural complexity, of compositional diversity, and of spatial heterogeneity, recognizing that those are attributes, defining features of natural ecosystems. And that's in contrast with a forestry approach that by design is trying to simplify to facilitate efficient regulated management and basically eliminate that variation. So please do not interpret this table I'm showing you as a good, bad, or anything like that. These are both valid, appropriate models that different landowners with different objectives will gravitate towards one or the other, depending on their mix of priorities. But when we're trying to explain to the public or to decision makers or to non-specialists what it is we're talking about, I think that this can be a useful tool, which is why I shared with you. Okay, so what moving on a little bit here, thinking about how do we implement this? Why is it a coarse filter? Two major themes. So first, natural disturbances and their legacies, and the forest development that follows disturbances provide for us a model for forest management. And the central assumption here is that if we use that sort of information to inform our management, it's going to function as a coarse filter. We're going to have greater success in conserving the species and processes that we're interested in conserving, because those biota evolved with and are adapted to the natural disturbance regime and the conditions that those disturbances and forest development generate. So we're not making this stuff up. it rests on that central, I don't even want to call it assumption, that axiom that that this is basically the biodiversity is the wildlife's home. And by looking at and learning from the natural disturbance and forest development processes, we have a better chance of sustaining them. All right, so I want to start with the concept of legacies. And I think it's an important one, and I'll tell you why here in a moment. But rather than starting with an individual type of disturbance, I want to start with a general framework for thinking about what persists through and is left behind after disturbances. Because even the most extreme natural disturbance events rarely remove all or even most of the biomass. So when we talk about legacies, we're talking about three major types of things. So it could be individual live organisms or their reproductive structures, or below ground parts. If they think about resprouting plants. There's obviously all of the dead material, the biomass that persists. Even intense stand replacement fires maybe only remove 20 to 30% of the above ground biomass in the most extreme cases. So there's a tremendous amount of organic matter that survives through disturbance events. And then a little bit more abstract organically derived patterns. And I'll give you a couple examples of that. So the obvious one that we think about immediately is live trees. And even in extreme fire events, we tend to have some survival of live trees, and they tend to be, not surprising, the individuals that have got the most fire resistant traits. Here I'm showing you intentionally a bunch of large western larch. Another element or important legacy are unburned or undisturbed. I'll use fire a lot here, almost without thinking about it because it's such an important process in our part of the world. But I guess I should acknowledge that there are lots of other disturbances, but I'm emphasizing fire just because it's the main thing that drives so much of our landscapes in the Northern Rockies. But unburned patches, undisturbed patches. So the picture on the right there is a good example of what I'm talking about. In a stand replacing large fire, you've got islands of unburned forests that survived. And all the way down, so the colorful map that I'm showing you, all the funny little black blobs there, those are individually mapped micro-refugia that survived through the rim fire in an intensively studied research site that we have in California. And it was about, oh God, I want to say it was 5 or 6% of the total area. And one of the things of following this that we've learned for a decade, well, obviously mortality is lower and survival is higher in those little microrefugia of the trees. That's what the data is showing you there. But we have totally different plant communities now, a decade later, developing in those microrefugia. So other types of legacies that persist through natural disturbances. We've got individual but live trees that are wounded and now have the opportunity to develop decadence, rot, wounds, broken tops, funk. Seed banks, I think we're all familiar with the great example of lodgepole pine. That's an example of a legacy, as would be resprouting from below ground structures. There's all the stuff underground that persists. This is my personal favorite, the post-fire morel flush. But the soil microbial community, is altered but still present after disturbances, and there to engage with and support the developing plant community as it redevelops above ground. So moving on. We start thinking about organic matter. Of course, we're thinking about things like snags, including really charismatic ones like these, downed logs, and then a little bit, I don't know, more abstract things like organically derived patterns, like which are going to be things like how trees and dead trees and disturbance events, whether it's wind or fire or others, contribute to things like soil formation processes or soil chemistry, so on and so forth. But I wanted to start with talking about legacies and their functions because it's a great place for us to begin to think about a coarse filter approach to management to conserving biodiversity. So what are some of the functions of these? Well, some of the obvious one is that they sustain individual species through the disturbance event, whether it's the persistence of individual living plants or of inocula or seeds or seed banks that are going to influence the rate of the developing forest after the disturbance event. The legacies are a source of energy. There's a huge pulse of wood, for example, that is available not just as physical habitat structure, but as a source of energy for the heterotrophs, the things other than green plants, the decomposer communities, the insects, and then the vertebrate wildlife species that use those. Another function, and this is pretty closely related, but there's some I think some important subtle differences here, is thinking about structural enrichment. And so when we talk about legacies and structural enrichment, I'm really thinking about as the post of disturbance community develops, the legacy structures that persist through the disturbance event contribute to the development of that structural complexity. And oftentimes, just by definition, they lead to an accelerated rate of development. And so you're able to sustain species that have particular structural requirements. Often these are things that we're thinking about related to large trees or large wood earlier in the development of the next generation. There are also, and this is a really critical point when we start thinking about long-term and multiple harvest entries or multiple rotations. These are, when we translate this into a managed setting, which I'll come to later, a source of future large diameter wood, the big trees and snags and things that we know are important for many species. Now, a really cool function of biological legacies left after disturbance events is how they influence larger landscape connectivity and suitability for many mobile organisms. And there's some work, it's kind of, I don't know, over a decade old now by Prue et al., but they did an interesting study where they looked at the literature, looked at over 1,000 different published wildlife biology studies that had data on patch occupancy, where they had a particular species and they looked across birds, amphibians, reptiles, mammals, I think invertebrates as well. And I did, and basically asked the question of the data: what best predicts patch occupancy? So, is this suitable patch of habitat occupied by a target wildlife species or not? And they wanted to know: is it patch size? Is it patch isolation? So, how far away it is from other suitable habitat patches? And what's the effect of the surrounding landscape matrix? And the big aha that came out of that study was that the matrix environment, that non-habitat or lower quality habitat that surrounds the target habitat patches, actually has a bigger effect. And so one of the things when we start thinking about legacies that are left behind after disturbance that often happens is that they facilitate the movement and dispersal and use of that disturbed landscape. I'll give you, I think, a really compelling and interesting example. This is some data from north central Washington, looking in subalpine forest and big burns, that looked at the use of these burned landscapes by Canada lynx. And what their data show, I think I've got it on the next slide, this is some of their data right here, is that not only were lynx using these habitats, the burned landscape, but they zeroed in on the unburned islands, with the pink in this map here, where they're calling it fire skips, as preferential places for use. And that's because they were preferred habitat for hunting their primary prey species, the snowshoe hare. So you had concentrations of hare in the unburned islands. And then as the lynx moved throughout the larger landscape, they showed a preference for areas of high cover, basically lower severity areas that had higher residual cover. So this is, I think, a good specific example that illustrates how legacies, whether it's unburned patches or just structure and live material that survived through the fire, influence how a wide-ranging animal might use that landscape. So one of the reasons to think about legacies and to start with that before we even start thinking about forest development or the disturbance events itself is that it helps us focus on what persists, what's left behind, I guess, or survives, maybe a better way to say it. Maybe it's not, because it's dead material too. But so much of the time, the language that we use when we talk about disturbance focuses on loss, and unconsciously that shifts our attention away from what survived, what persisted, whether it was alive or dead, and how that maintains continuity from the pre-disturbance to post-disturbance habitat and ecosystem. So I think it's a really important way to sort of train some of our thinking and some of our language in a way that shifts the focus from removal or loss to persistence and continuity. Okay, so I want to shift gears now and talk a little bit about forest development. And I'm going to just run through quickly, and I know that for everybody, this is stuff that you know in your sleep and by heart and see it every day, but I'm going to do it anyway. But I want to run through two examples. So the first would be a low severity frequent fire regime, and we'll use ponderosa pine and dry mixed conifer forest as the example. And then we'll look through the stand replacing and mixed severity fire regimes that are exemplified by a western larch in the colder, drier, or colder, moister mixed conifer type here in western Montana. I know that this is familiar stuff, but let me run through it. So ponderosa pine forest. We'll start here, and I'm giving you the idealized case here of a forest with an active fire regime. And we know from historical studies, we know from the places on the landscape where fires are allowed to burn more frequently, that the condition that develops in an active fire regime is one that's pretty distinctive, and it's got some real obvious attributes. It's got open, low density stand structure, tends to have low fuel loads, and it tends to express itself in a sort of a patchy mosaic pattern. And we look at the actual dynamics here. One of the hallmarks in an active fire regime is strongly aggregated, patchy tree regeneration. So how does this happen? And what are the implications for forest dynamics overall? Well, if we look across the forest, you obviously there's constantly going to be mortality going on. And occasionally we have punctuated mortality events where some of the big old trees die. Often this is going to be associated with a bark beetle outbreak, or at least some level of activity that provides some patchiness and heterogeneity in the fuel bed in this active fire regime forest. And those big trees, as they come down, at some point, they're going to provide an aggregation of coarse fuel that's going to burn. When it does burn, may burn hotter, or at least for a longer period of time, and create some opportunities in a patchy way for tree regeneration. And then set the system up in the context of these recurring fires for this sort of open, fine-grained mosaic structure that's maintained by these recurrent fires. So if we start over here with the picture on the right, you've got a developing group of seedlings moving to saplings, and you'll notice around them the fuel bed is still pretty low. And so there's a degree in the early years of protection by low, very low surface fuel loads. But then through time, the next, at some point, successive fires are able to burn through, and density-dependent mortality processes, as well as those fire events that tend to preferentially remove the small and less fire-resistant trees, maintain that open stand structure. And so through time, I've got these great pictures from Bob Van Pelt here. The disturbance regime is driving forest development in a way that basically maintains an almost equilibrial condition. It's got low fuel loads, low competition environment. This is, I think, a really important thing here, where you're maybe at 20 to 30, maybe 35% of the theoretical carrying capacity, what full stocking might look like in this sort of environment. But the trees, because they've been exposed to this chronic, frequent fire regime, you've got a relatively high level of resistance and resilience to any given fire event. They're widely spaced, the crowns are high, the fuel loads are relatively low, so your total energy release tends to be relatively low. Residence times tend to be relatively low. But then you also, an important function of these fires is they're creating those patchy regeneration opportunities. And so we're left with a structure that contains a full range of tree ages and sizes, albeit at really low densities, as well as dead wood. And this is, I think, something that we tend to forget about, because so much of our management in the ponderosa pine and dry forest is focused on fuel reduction and just correcting the conditions that we have right now, that it's easy to forget that these forests actually do have and maintain populations of large standing tree snags and down logs. And then that other attribute that comes through is the spatial variation apparent in the stand structure, that mosaic condition. Okay, So let's switch gears and just do a quick refresher on the stand replacement and mixed severity fire regimes. So here we've got a recent fire burning up in Glacier Park. This is the high severity stand replacement sort of disturbance regime that we're familiar with. I do want to emphasize, though, and this is crucial, that even in the most extreme conditions, we rarely have complete stand replacement. You might have big extreme weather-driven events where you have a very active burning period with high mortality, but even in those events, you still have some survival, especially the most fire-resistant species and size classes. And as we progress through that sort of linear, predictable stand development cycle, you've got, the emergence of a new cohort in the understory. We'll note that there's abundant dead wood persisting. Here we're 30 years after the stand initiating fire, still have all kinds of standing snags. These are mostly larch snags here, and abundant dead wood in the understory. By the time we get out into sort of the maturation or mature stage, so we're 80 to maybe 150 years old, that initial pulse of dead wood is really largely down and decomposed, but now we've finally got some trees that are big enough that when they do die, they're going to begin to fill those large diameter size classes. One of the things that and I talked earlier about legacies and that idea of structural enrichment, and this picture really illustrates it nicely here. I think you can see this older cohort of emergent trees that persisted, survived through that initiating stand disturbance, stand initiating fire event. And so they're enriching this maturing forest. So we've got sort of a two-aged class structure here. And then given enough time in the absence of another stand replacement event, we're going to get to a condition that's, I don't know, so well known, sort of engaging, big trees, lots of dead wood, all of those sorts of things that are used by things like pileated woodpeckers, big aggregations. This is a little porcupine using this great big pile of logs. Now, I do want to point out that in western Montana, in really most, if not all of the Northern Rockies, we don't just have stand replacement fire regimes. Most of the fire events really express as mixed severity fires. And I would argue that because we put out so many natural ignitions now, we really have underrepresented on our landscapes the mixed severity events. We tend to have, I think, greater representation of the really extreme weather-driven events because those are the ones that we can't put out. But if we look across, here's a representative study landscape. Here, these are big fires. They burn, tens of thousands of acres over days and weeks. And so they're burning through many burning periods, through lots of different weather conditions, through different initial conditions. And that generates a lot of variability, everything from unburned residuals to, here, the full gradient of possible mortalities. And that can express even at the scale of individual stands. So this is an intensively mapped and measured just 10-acre area. And we see everything from fire refugia to stand replacement just in this 10-acre patch. So our fire regimes and fire events are good at generating a lot of variability in their effects and in the stand structures that result. And then just to make things even more complicated, I think this is both fun and maybe it can be frustrating a little bit, but we do need to acknowledge that reburns happen in these stand replacement regimes or mixed severity regimes. And so if you look at this crazy conceptual model I'm showing you here, if we go from number 1, which is showing short initially after a high severity fire, you can see a lot of legacies. We see an establishing cohort in the understory, and that moves through succession and structural development to condition 3, which moves through that to condition 4, this more structurally complex sort of thing that I've been showing you pictures of that might illustrate that. But then what happens when this is reburned or interrupted with a lower severity fire like this? We get all sorts of interesting structures that can arise from that circumstance. And I'll just point out that we still have a tremendous amount of legacy deadwood, of legacy live trees. The understory community is there, it's resprouting, and you get really interesting stand structures that can arise from these compounded disturbances. Like there's multiple cohorts here from successive mixed severity fires laying on top of each other. I guess the take home here is that in our part of the world, we don't have to restrict ourselves to thinking about just the classical stand replacement disturbances with really long fire return intervals. In fact, we have the potential for quite a bit of variability in there. Okay, so after this quick review of thinking about disturbances, natural forest development under different disturbance regimes, how do we translate that, or how does ecological forestry translate that into a coarse filter approach for management? And I want to start this part of the talk by just being really direct and saying that the goal is to not somehow perfectly recreate fire effects or blowdown effects or bark beetle outbreaks or something like that. That's not what I'm talking about. And it's obviously not possible if we're going to remove some biomass and utilize it as a product. But the goal, and I think it's so obvious it doesn't need to be said, but I'm going to say it anyway, is that we want to use our knowledge of these natural patterns and processes to inform how we go about designing our treatments. And going back to that coarse filter approach, it's because this is the biota's home. This is what they have evolved with and adapted to. And by using those natural disturbances and developmental models as a guide, we have a better chance of sustaining the majority of biodiversity. So 3 major themes here then that we can focus on in designing forest management systems or individual treatments that draws on this sort of an ecological foundation. The first is to integrate legacy concepts into our prescriptions for harvest. Oftentimes this is emphasized or treated as something exclusive to a regeneration harvest, and I would challenge that. You can integrate legacies in your design of everything from pre-commercial thinning treatments to individual or group selection treatments in a ponderosa pine forest to a final end of rotation harvest in an even-aged system. Works everywhere. And we can take inspiration from looking at natural disturbances and the legacies that they leave behind. This theme of managing for complexity, diversity, and heterogeneity. And then I think a hard thing to do, but it's not impossible, is practicing our stand level silviculture, our management units, which tend to happen at sort of 10 to 100 acre patch sizes with a large landscape view. So legacy concepts. I think this has sort of been around for a long time now that almost everybody knows what I'm talking about when I talk about variable retention harvesting or just legacy concepts, period, in harvesting entries. But there are 3 fundamental things that you need to address. What am I going to retain? And so that might be particular types of structures, trees, snags, logs, particular size classes, particular species or life forms, shrubs, hardwoods, whatever. How much of it do we need to retain and in what pattern? And, I have no answers for you there. That's up to you. And you have to use your judgment and your resources, draw on experts who can help you sort of parameterize these questions. The kind of silly answer is you need to do enough. You need to retain the things and enough of them to achieve your objectives. But there's no simple answer there. And I think that's kind of the fun part. But what does it look like? I'll try to give you a few representative examples here. And most of my pictures emphasize some sort of a regeneration harvest in western Montana. And you can see in this picture here, well, if we're taking some level of inspiration from a natural disturbance, what tends to survive fire events? Well, it tends to be the larger and more fire-resistant individuals. Snags, we tend to have a harder time with. You can see in this picture, we've got a few. But, oftentimes we're thinking about retaining what big snags we have, and we're thinking about leaving behind candidates in the future. Here we've got some contrasting options for pattern. So depending on what you want to emphasize, if you're concerned about, I invoked snowshoe hares and Canada lynx, and I realize this picture is not appropriate for that. But if you want to do something like retain dense, very high cover patches for snowshoe hare habitat, well, that might shift your retention strategy to emphasize patches, blobs, aggregates, where you're going to provide enough habitat of the right structure for that individual. I don't want to stray into a fine filter view, but that's an example of why we might gravitate towards one pattern versus another. Oftentimes you're going to want to have a mixture of the two. You can see that a little bit here in the distance, where you've got sort of an aggregate there in the middle and the back, and then widely distributed residual overstory trees that are going to provide those structural enrichment functions as this forest develops into the future. Here we've got a gradient. This is a picture that Justin Croteau shared with me. And this is sort of a gradient in overstory retention moving from the edge of the harvest unit out into the interior. And so part of what he was trying to achieve here was a degree of sort of softening the edge and providing a bit of a transition. And here we've got an example where we've got overstory retention combined with a broadcast burn after the treatment. And you can see the good regeneration, and we've got snags and still a big population of residual overstory larch in this example that's persisted through. So one of the things that is important when we start talking about green tree retention in harvest systems as a coarse filter strategy for conservation is that the intent is for those retained structures to more or less be permanent retention. And it's not a seed tree or shelter wood in the classical sense where the intent is to go back and remove those. It's to retain them and let those residual trees become the large diameter complex component of not only this generation, but potentially 1 or 2 or 3 generations of forests down the road as they persist through multiple harvest cycles. And it's based on the recognition that it takes in some cases several hundred years to produce a really large, long-lasting snag or log. And so I want to emphasize that point because it's something that, and these are, I guess I'll say, decisions that none of us are going to get to make. This is something that the future generations of foresters that we're leaving for them, but this is a big part of the intent. Okay, I want to illustrate the second point here, managing forests for complexity, diversity, and heterogeneity by looking at a ponderosa pine dry mix conifer example. And so, I'll say that these themes, they're represented in what I was showing you here. I mean, there's, a lot of the complexity and structure and diversity is represented here, but I'm really was focusing on the legacy concepts. If we look at dry pine forests, so if we take everything that we've learned, the structural development stuff I presented earlier, and there's just an ungodly amount of literature from 30 plus years now of people working on how do we restore, reduce fuels, and ultimately sustainably manage these fire-frequent, fire-adapted dry pine and mixed conifer forests. We've got sort of a very familiar list of things. One of the big ones, though, that if we're thinking not just about a simple fuels treatment, but how can we set up these dry, frequent fire forests for long-term sustainability, we actually have to think about regeneration of the target fire-resistant species, which is something that, we don't normally talk about in a fuel reduction treatment. But, so what are some of the simple things that come through here? So obviously we've got the retention concepts. We're going to retain the things that our natural disturbance regime tends to retain. And that means we're going to remove the things that the natural disturbance regime tends to preferentially remove. You really should try, whenever possible, to use prescribed fire in this sort of a setting. If we're really going for a coarse filter, conservation-focused management, it's such an integral process in the structuring of these forests that it's hard and nobody wants to do it because it's expensive, it's risky, it takes, there's regulatory complications, all of those things. But if you can do it, work towards it, it's the best way to deal with the surface fuels. It's also a great way to create regeneration opportunities for the species of interest. And it's just, it's the major disturbance process that created fire resistance and resilience in that characteristic structure period. But let's look here with a focus on spatial heterogeneity. This is a topic that I've worked a bunch on, so I've got a lot of material on it. But one of the things that we often end up with in this sort of environment is a low density stand structure that's really fire resistant, that looks absolutely nothing like the complex variable mosaic that a natural disturbance regime promotes. And so you've got example conditions, a corresponding map there. And I'd contrast that with conditions and patterns more typical of that frequent fire regime, which are strongly patchy, that derive from that strongly patchy regeneration. And you get all sorts of different outcomes because of that. I'm not even going to go into here. But there are lots of ways to go about managing for that sort of patchiness, along with the other elements of complexity and diversity. But one of the things that we've pushed forward is an approach that basically partitions your forest into different spatial units, individual trees, tree clumps of different sizes, and openings. And we've found this to be a relatively efficient, easy to implement sort of shorthand for describing that spatial variability and translating it into prescriptions, marking guidelines, or just, designation by description sort of operating guidelines that an operator can just go and implement. So if you're interested in using, in this case, the ICO approach, I'll give you just a quick example right here, what it might look like. Basically, you're going to go through and implement your design criteria, or develop your prescription design criteria, focusing on your different things. What are you going to retain? We're going to have some species and size targets, some general guidelines on, are we going to retain some decadent wildlife trees, come up with your target residual density, but then express that residual density in terms of different sort of clump sizes. So numbers of individuals and numbers of tree clumps of different sizes. And then don't forget about large openings and maybe even some reserve areas that you don't want to enter. So getting some of that variability at a little bit coarser grain. And that's going to give you some, something that might look like this. I think the other thing that we've learned from trying to implement, or from lots of implementation of ICO treatments, is that it's really important, if one of your goals is to deliberately create and maintain spatial variability, to give yourself and your operators some flexibility to work with the conditions that are on the ground. And one of the great ways to do that is to express these pattern targets not as a per acre target, but as a total unit target. And so rather than saying, well, I want 3 clumps of this size and 2 clumps of that size on every acre, instead we say, well, here I've got a 10-acre hypothetical unit. Find me or leave me this many of these types of structures as you encounter them, or as you have the opportunities to create them. And that can actually, do a lot of things for you. It can give you an opportunity to create other bigger gradients as well. And you can see in the map here, a gradient from low density to high density as you move from the upper right to the lower left. but it gives you some flexibility. It makes it more efficient and realistic and implementable. Okay, so that's a little bit on pattern, but then thinking about, I guess the thing that I've seen over and over now in the dry pine and mixed conifer forest is that we need to really begin as we move through the first round of fuel reduction and restoration treatments in these forest types, and now we're trying to transition to long-term management and sustainability using a coarse filter approach that'll conserve biodiversity. Well, one of the things we got to do is regenerate the right tree species. That means not just having an ocean of Douglas fir taking us right back where we came from, but promoting those pine and in some cases larch regeneration in those big openings. And don't forget about the big wood. I think this is something that I don't know, I guess I'd kind of forgotten about it, but there are at lower densities, but there still are large diameter and relatively persistent big pieces of wood in a functional, frequent fire environment. And so we've got to make sure we implement, I'll say, our retention treatments in this sort of environment in a way that's we're allowing for some future recruits, and we're going to leave those elements behind. Now, there are lots of other things beyond these two examples that I've given you. I tried to give you a couple of case study examples that matched with the structural development examples that I gave you, but we might take some more sort of finer scale tactics to managing complexity, diversity, and heterogeneity. So we might do things like manipulate species composition with planting. We might do really targeted things like decadence creation, where you are topping a tree, or even doing something crazy like inoculating trees with heart rots or things like that, where you're in a really structurally impoverished environment and trying to get some of that back. So I guess I want to acknowledge that, but I don't have time to emphasize it. And then the third really pillar here of implementing a coarse filter approach is paying attention to the large landscape context as we implement our stand level treatments. And that's a really hard thing, I think. I mean, it's there are lots of tools, and there's not nearly enough time to talk about what this looks like. And for many of us, many of you, you may not really have the luxury, because you're not managing tens to hundreds of thousands of acres. You might be managing an individual parcel of 20 or 40 or 60 acres for an individual landowner. But that doesn't mean, if you're in that setting of managing an individual small parcel, that you can't pay attention to what's going on at the larger scale. And I guess I'll go back to this, my favorite landscape picture here, and just sort of point out to you that if we pick any given patch, any given stand in this view, its functioning is influenced by and depends on what's going on around it. Because an organism that wants to get there has to traverse the surrounding landscape. Disturbances that might spread through this landscape, whether it's fire or bark beetles or whatever, they're not going to interact just with the one patch on the ground. They interact with this whole landscape in a connected way that crosses scales, which is what I'm trying to illustrate with this series of nested pictures here. And we can understand our individual stand, which would be sort of the top right polygon there, not just as an entity that exists on its own, but that is a member of and participates with higher levels of organization all the way out to the ecoregion. And, this is obvious, but we need to recognize that our land ownership patterns, our management systems, transportation networks tend to disrupt the patterns that are generated by, or be at odds with, the patterns that are generated by the biophysical template and by natural disturbances. It just, that's just a fact, and you can see it. The classic example right here is the checkerboard pattern. So what can you do? I think that the place to start is just to periodically ask yourself, are the things that I'm doing at the stand level contributing to landscape patterns that are broadly consistent with what the natural disturbance regime generates or not? And I think if you just use that as a starting point and make adjustments as needed, you're going to accomplish quite a few of the things that you'd like to accomplish with regards to having a successful coarse filter approach. And, there are some specific things that you might begin to look at, thinking about how the edges of your unit that you're managing, are they hard or soft as you transition to the next ownership? What's the diversity of patch age classes or structural conditions across the landscape? And how does that fit in with what you think it ought to look like based on what the natural disturbance regime would generate? How does your road network interact with things like the stream channel network? That's obviously something that is a major regulatory thing that you're often going to have to encounter. But these are some of the issues, and just one overarching question I think is going to help you navigate this. Here, this is obviously is a salvage after high severity fire, and one of the things that I'm trying, the main thing I'm trying to illustrate here is you've got a pretty sizable 100% salvage with zero retention that's been left behind here. And that's an environment. This is not a criticism of salvage harvesting, but the point is that treatment that I'm showing you on the screen right now, well, there's not a lot of natural analogs for that. And something as simple as leaving some level of retention across there might make a relatively big difference for some species. Now, I'm not really worried about, does this landscape have enough snags on it to support, say, blackback woodpeckers? This individual harvest hasn't done anything adverse, I would argue, in the context of this 50,000 acre fire. It's a drop in the bucket. But as this forest develops through time, it's going to be structurally impoverished because every single stick of wood has been removed. Here's an example. I pulled this just off of Google from an arbitrary location in the southeast. And, here's an example where if you ask yourself that question, are my treatments at the stand scale creating patterns and processes on the landscape that are broadly consistent with the natural disturbance regime? I would say there's only one answer here. The answer is no. So periodically, basically popping your head up, looking around, and saying, what's the kind of cumulative effect of what I'm doing here in this place going to be on the larger landscape, and make some adjustments as needed. Now, I want to come back here. We're getting to the end. I want to leave at least a minute or two for questions, and point out, I gave you this example earlier that doing retention at the stand scale can really have meaningful outcomes for connectivity and movement by mobile organisms through that landscape. So you kind of get a little bit of a freebie sometimes in terms of large landscape outcomes just by doing some things at the stand scale. And then, here's just a quick laundry list of some other things that when you zoom out, you want to have some consciousness of. The special habitats and hotspots, the obvious one that you're going to deal with frequently is going to be riparian forests and the channel networks. But then things like wetlands, cliffs, other sort of special habitats are going to be part of a larger landscape look and how your management's interfacing with the other parts of your bigger landscape. Okay, so coming to the end now. One of the things that I want to acknowledge is that using this sort of a coarse filter approach, it's hard. It takes creativity, it takes commitment, it costs money. We're talking about leaving more things behind structurally than we would have otherwise, and those are real. Sometimes it means some training. It might mean lower production rates. Those things can be mitigated and improved through time, but I guess I just want to be really direct that it's not necessarily business as usual, but don't forget that you're using this sort of an approach in response to and in support of a landowner's objectives, where the landowner has said, hey, this is a priority for me. This is one of my objectives. So I guess the take home there is to make sure that the tools and strategies that you're using mesh with the objectives. And I'm acknowledging right off the bat that there are always going to be trade-offs. I think that it's important to recognize that many places that we manage or you manage, you're starting with structurally impoverished initial conditions. And that's just a fancy way of saying that there are far, far fewer big trees on the landscape now than there were historically, and there are far, far more little trees than there were historically. And so a lot of times you have to dig yourself out a little bit, and that may be something that the next generation of foresters, you're leaving them something that's going to be easier to work with or more options. But I just want to acknowledge that that's hard. One of the things that I think we struggle with the most, and I have seen the most committed landowners and land managers struggle with this, is leaving some dead and dying big trees to fulfill their ecological functions on the landscape. I have seen so many examples of committed ecological foresters, for example, chasing the bugs. We have to try, if we're going to use this sort of an approach, to exercise a little bit of restraint and let some of the dying stay out there on the landscape. Not all of it, not even most of it, but some of it, because that tends to be the thing that we deplete with our management through time. And so it takes active effort there. And then variability, that is a hard one. And at least while you're getting started, going really explicit with layout and guidelines can be a really helpful way to get your operator trained or get your whoever sort of calibrated. I don't know, having some real guidelines. All right, now wrapping this all the way up. I guess the take-home theme that I've been emphasizing here, and hopefully that I leave you with, is that I'll just leave you with it as a statement that your best bet at a forest management approach that functions as a real coarse filter for biodiversity and wildlife conservation is going to be an approach that is informed by and based on the natural disturbance regime and natural forest development, because those are the conditions that the biota evolved with and are adapted to. It's their home, and if we can inform our manipulations based on natural disturbances especially, we're going to have a better chance of success. So with that, I think I'm done. That's my last slide. And there may be time for a question or two, and I'm happy to take feedback and questions.
Thanks, Andrew.
Yes.
I'm getting a little feedback. Can you guys hear that?
I'm going to see if I can stop sharing my screen so I can see people's faces. There we go. Well, nobody's got their cameras on.
So I asked for people to type their questions into the chat, and nobody took me up on that offer. So, I think two things. One, if you maybe are available later on to take questions,
Absolutely.
This, maybe type your email into the chat or something like that, or however the best way to get a hold of you is, and folks can ask those questions. I went ahead and threw one out there. I typed up a couple of them, but I know you kind of touched on some of them as you went along, but one of them was the whole idea of climate change and how the future predicted climate does not match up with historical climate. And this is, a really tricky question, but one that, I think some of us who are trying to apply ecological forestry are struggling with is that future disturbance regime and climate is not likely to be the same to what historically was, and what kind of things are coming now that can help us kind of model that and determine like how is maybe a what historically was more mixed fire regime and maybe a little bit wetter like a grand fir climax going to dry out and transition, and like how extreme should we go with trying to manage for the potential of the future range of variability.
Good question. I'd say a couple things really quickly. One, in the dry forest now, and I know that's not your question, but I'm going to start with the dry forest. The simple answer for how do we do climate change adaptation in a dry forest? What you're trying to do is buy hang time. You need to reduce stem density and shift composition to fire and drought resistant species. That's it. Our current condition across most of the landscape is way, way, way out of alignment, even with historical conditions. So don't be confused here. I'm not saying recreate historical conditions. What I'm saying is reduce the number of trees sucking water out of the ground and create conditions that when the next disturbance event is going to arrive, they're more likely to survive. So what you're trying to do is buy a little bit of hang time to achieve a more gradual transition as climate change manifests over the coming decades. Now, we go to your question about what do you do in moisture forests to think about transition to drier forests. So one of the things that you can do is take or turn to your sort of science partners, whether you're a federal agency person that might draw on the research station or whatever. And a great tool is to have modeled future climatic water deficit is a pretty useful product. So as you look at sort of what's a good way to think about how plants experience drought across the landscape is how much unmet evaporative demand did they experience over the course of the year. And that in our topographically complex landscapes, deficit can vary a lot. Like on a steep southwest aspect, it could be high. You flip the hill over to the other side, and the topography puts you in a much lower deficit, lower drought stress environment. So translating climate change forecasts into that type of product. So what does climatic deficit, what do we expect it to look like in, say, mid-century or later in the century, can help you do some sort of spatial prioritization of where you might want to start tweaking species composition or structure or fuel loads to sort of ease the arrival of climate change and your ecosystem reorganization to it. So I'm happy to talk more about lots of other things on this, but I don't want to take any time from Tori. I'm already over my time here. So I'll be around later on. I'll disappear for a little bit right after lunch, but then I'll be back for the afternoon sessions. And then I'm available on email as well.
Thanks. I could have saved it, but I didn't want to let you off the hook too easy. No. All right. Thanks, Andrew. Really appreciate that.
Yeah.
Andrew
Thanks for having me.
his email into the chat there if you want to follow up with him after the fact. So I'm going to go ahead and hit stop recording.